Election held among 4 candidates using a voting method we call X. The winner of the election is candidate A. Okay, so A wins first election. Due to an irregularity in the original vote count, a recount is required. Before the recount takes place, candidate B drops out of the race. In the recount, still using the same method, candidate D wins the election. And in election 2, B dropped out. Based on this information, we can say that the method we used violates what criterion? Independent of irrelevant alternatives. So it should be irrelevant that B dropped out, right? Because A was the winner. It should be irrelevant that B dropped out. A should remain the winner. But B dropping out seems to have caused D to win instead of A. So that's independent of irrelevant alternatives. The one that violates that one was plurality with elimination, I think. Nope, you're right. That's pairwise comparisons. That's pairwise comparisons. Yeah. Uh-huh.
I was going to pick that right now. It didn't seem like it was possible. It's here. I kept reading over and over trying to find it. Yeah.
Okay, so we have an election held among 5 candidates. A has a majority of the first place votes, but B wins the election. Which method could have been used? Okay, so we're looking for methods where it's possible to get a majority but lose. Okay, so it's definitely not pairwise comparison. I'm sorry, it's definitely not plurality. Because plurality, if you have a majority of the votes, then you automatically have the most votes. Okay. No, you can win without a majority, but it's impossible to lose with a majority. Those are 2 slightly different statements. Yeah. So it's not pairwise comparisons, the one we learned last class. That was one of the conclusions we came up with, is that if you have a majority, you're automatically Condorcet, which means you can't lose in pairwise comparisons. Plurality with elimination, that one was, as soon as someone gets a majority, they're declared the winner, right? So if someone has a majority, they're the winner automatically. So you can't have a majority and lose if you're using plurality with elimination. But board account, the one with the points, we did do an example in class where we had somebody who had a majority of the votes lose using board account. So that was the problem. That was the problem with board account, is that it can violate the majority criterion and the Condorcet criterion. So it had those 2 big drawbacks. Yeah.
Last question.
Yep.
How do I know when to use addition or subtraction on the problems where the formula, 500. The formula n 5 minus 4.
I don't know what you're talking about. Okay. Oh.
Yeah. There were scenarios when you use addition, then it was scenario subtraction.
Oh, okay. All right. Yeah. So there was, so this one was like add up all the numbers from 1 to 550. Was that it? Okay.
One was like that.
Yeah.
And then the subtraction one was handwriting.
I'm sorry, I don't know what you're talking about. We're going to move on to 1.6, which is ranking. Okay, so this is what we do when we need to know the place of each candidate and not just who the winner is, but we need to know who comes in first, who comes in second, who comes in third, and who comes in last. Okay, so we're going to go back to the math club election. Instead of just electing a president, we're going to elect a board: president, vice president, secretary, treasurer. So first place goes to the president, second place will be vice president, etc. So each of the four methods that we've studied allow us to rank the candidates with this really natural extension called extended ranking methods. So for extended plurality, the candidate with the most first place votes gets first, the candidate with the next most first place votes gets second, etc. Okay. And you do the same thing with board account. Whoever has the most points in board account wins. Whoever has the second most gets second, third most gets third, etc. In plurality with elimination, you rank the candidates in reverse order of elimination. So the first candidate that you eliminated gets last place. Whoever gets eliminated next gets. You still eliminate them. Okay. Yep. And you just say you're out first. You're going to come in last. The candidate that gets eliminated next comes in second to last, and you just keep doing that until someone has a majority. Whoever has the majority wins. Next most votes is second, etc. To extend pairwise comparisons, that's another 0.1. It's just whoever gets the most points wins. Whoever gets the second most points is second, etc. Okay. So I'm going to have you take this math club election, and I want you to do extended all four methods. So you're going to have to do all four methods and rank the candidates for all of them. And I gave you, I think, plenty of room to work, and there's a little chart at the end where I want you to put down the results. Okay, so for plurality, who came in first, second, third, fourth? Borda, first, second, third, fourth. This. So we'll do plurality first. So plurality, you just count first place votes. Candidate A has how many? 14. Yeah. Candidate B has 4. Candidate C, 11. And candidate D has 8. So in first place, we have A, second place C, third place D, last place B. A, C, D, B. So I'm going to go to the table at the end, and I'm going to do A, C, D, B. Okay. All right, so now I'm going to do board account. So in Borda, we calculate points, right? So because there are 4 candidates, first place is 4 points, second place is 3, third place is 2, and last place is 1. And then we do 4 points times 14 ballots is 56. 4 times 10 is 40. 8 times 4 is 32. 16, 4. And then we give out all the second place points. 3 points for these 14 ballots goes to B, and that's 3 times, what is it? 42. And 3 times 10 is 30. 3 times 8 is 24. 3 times 4 is 12. 3 times 1 is 3. And then we give out our 2 points. We have 28, 20, 16, 8, and 2. And then we give out our 1 points to each last place candidate. So D has 14 here, A has 10, 8, 4, 1. Then we add up each candidate's points. So A, 79, B has 106, C, and D, 81. So first place goes to B, second place C, third D, and then A. So B, C, D, A is my ranking for Borda. So I'll go down here and I'll put B, C, D, A. That's quite a stark difference. C and D both got second and third in both of them, but A and B flip-flopped from first and last to last and first. It's kind of crazy. Okay, so continuing our group work, let's do plurality with elimination. So plurality with elimination just starts with plurality. You write down the number of first place votes. So A is 14, B is 4, C is 11, and D is 8. And how many people voted in this election? 37? Okay, so how many is a majority? 19. Does anybody have a majority? Okay, so you're going to need 19 votes to win. Nobody has it. So we eliminate the candidate with the fewest first place votes. That would be B. So we're going to get rid of B, which means that B comes in last. Okay. So I'm going to go to my chart and say B's in last place there. All right, now I'm going to go back here and I have to decide who those 4 votes go to. So I look at the column where the people who had B in first, and their votes are going to revert to the second place choice, D. So I'm going to give 4 votes to D, which makes 12 votes. Does anybody have a majority? No. Okay. So who should I eliminate? C, which means C comes in third, second to last. Okay, so C's 11 votes, we have to decide who they're going to go to. So these 10 people had C in first. They had B in second, but B's already gone. So their votes are going to revert to D. So I'm going to put 10 more with D. And then this one person had C in first. They have D in second. So they're going to get the other 1. So that gives D 23 votes. A still has 14. So who wins? D has a majority now. So D comes in first. And that would just leave A to come in second. Yeah.
My question was,
Okay.
when I missed the first 2 classes, when we talked about board account,
Yeah.
that you eliminate classes first, or even if you were doing it, you said you
For
eliminate
board account?
for the board.
No, this
Oh,
is
sorry,
plurality with elimination. Yeah.
But I didn't understand that if there was no majority vote, you keep eliminating.
Oh, okay.
So when I was doing some of the questions on the homework, the first part was like just find the winner, or find
Yeah.
the winner, and then the second one had something to do with like continuing on the problem. So I wasn't eliminating anything else, even though there was no majority.
Okay,
So I
so
kept
this
getting
is
wrong
clear
answers. I
now?
couldn't figure out why.
Okay.
Yeah.
Yes, you eliminate until someone
I
has a
get it.
majority. Okay, good. Good. Okay, so finally, pairwise comparisons. So I have 4 candidates. I'm going to do all of the head-to-head matchups. A versus B, A versus C, A versus D. That covers A's matchups. And then B's matchups will be B versus C, B versus D, because I already did B versus A. And then C's matchups, I just have to do C versus D. So those are all my matchups, 6 of them. In A versus B, in every matchup, we're going to force all, what was it, 31 people? 33 people? 24, 32, 37 people. All 37 voters, we have to force them to choose between the head-to-head candidates. So these 14 people, if they had to choose between A and B, who would they pick? A. And these 10 have to choose between A and B. Who do they pick? They have to choose between A and B. They would pick B because they have B ranked above A. So we give 10 votes to B. And then 8, these last people, they have to choose. Who would they pick? B. And these 4 people have to choose, and they would pick B, because they have it ranked above A. And then this last person, who would they pick? B, ranked above A. Okay, so B wins that matchup. Okay, so you guys tell me, who wins A versus C? C, okay. A versus D? B versus C? B versus D? And C versus D? C. Great, thank you. All right, so A ends up winning 0 matchups. B wins 1, 2. C wins 3. And D wins 1. So C is going to be the winner. B is in second place. D is in third, and A is in last. B versus D? Yeah, let's go through it then. So these 14 would choose B. Okay, and then these 10 would also choose B. And these 8 would choose D. 4 would choose B, and 1 would choose D, so B has the most. Yeah, once somebody gets a majority, you don't have to go through the rest of them. Yep. So my ranking here is C, B, D, A. C, B, D, A. Yeah, totally inconsistent. Different winner in every case, different order in every case. Kind of crazy. Okay, so now we're going to discuss a somewhat more involved strategy for ranking candidates, and these are called recursive ranking methods. So a recursive process is like a feedback loop. The output of each step determines the input at the next. So in elections, the process is to find a winner of the election. Okay, so you just do the straight up regular process that we have learned so far. Do the method, determine the winner, that person gets first place. Okay. Then you remove that person from the preference schedule. Okay. That person already got first place, take them out of the running, they get the first place trophy, right? They're out. Then you're going to play again for second place. Rather than just saying whoever had the next most points getting second place, you like game over. Do everything again with a new preference schedule with that first place person gone. So it's like a consolation match, right? You play for second place. So you do the whole thing over for second place. So you're going to have to carry out each method 3 times to do the recursive thing. And you just keep repeating until everyone's ranked. Okay, so we're going to do the 4 methods using recursive. I'll do plurality with you. Okay. So here's plurality. So we carry out the method once to determine the winner. Count first place votes. So we say A has 14, B has 4, C has 11, and D has 8. So A is the winner, right? Okay, so A wins. A is going to come in first place. So again, I gave you a little chart. These are just the extended ranking methods that we already did. We're going to put the recursive methods here. I now know A comes in first. I just did the method. A came in first. All right, so we come back over here to figure out who gets second. Before, we would just give it to C because they have the next most votes. This is going to be different. We're going to eliminate A from the preference schedule. A gets the first place trophy. They're out of the running. We're going to play again for second place. So we eliminate A from the preference schedule. And then we would say, okay, round 2, A is gone. So then we count up first place votes, right? So these 14 people, since A is gone, they would vote for B. Right? So B has their original 4 votes plus the 14 that are reverting to B because A is gone. So B has 4 plus 14, which is 18. C still has 11, and D still has 8. So second goes to B, because B wins. B is the first loser, right? Anybody remember those t-shirts? Second is the first loser. Nobody remembers? Okay. So B wins the matchup of the losers, right? We'd say A is the winner, remove them, we play again with all the losers. B is the winner of the losers, so B gets second place. This is all plurality, right? Then we do it again, right? This time, B now, they got the second place trophy, so we're going to take B out of the preference schedule. B is gone. And we have to count first place votes again. So we have A and C are the only candidates left. Sorry, C and D. C and D. Okay. So C, now that A and B are gone, they get these 14 votes. So C is going to have 14 plus 10 plus 1. Okay. And yeah, that's the 10 plus the 1. Yeah. Yeah. Just writing it all out, yeah. And then D has these 8, their original 8, these 4 from B, and that's it. Okay, so C has 25, D has 12, so C wins this matchup, okay, which leaves D in last place. So C wins the matchup of the total losers, the bottom of the pack. So C gets third place, and D gets last. Make sense? All right, you guys attempt the other 3. So for Borda, okay, we've already determined the winner once, right? We already did all of the points and stuff, and we got A has, what was it, 104? 79? 79. B had 106. C had 104. And D had 81. So that makes B the winner. Number 1. Right. So I'm going to go to my little chart. And for Borda, in my recursive results, first place is B. Okay. Now I'm going to eliminate B. B is out of the running. They already got their trophy. We're going to have a runoff for second place. So I eliminate all the B's because B already won. Then I do Borda again, but this time it goes 3, 2, 1 for the points. So do all my first places. So A, I have 3 points times 14, which is 42. 3 times 10 is 30. 3 times 8 is 24. Oh, whoops, B is gone. So those 12 points go to D there, because D is in first place now that B is gone. And C has 3. Actually, I think it might be clearer if we just write a new preference schedule. So we're going to have 14 goes A, C, D. 10 goes, oh yeah, so notice that this column and this column with B gone both have CDA. Now that B is gone, they're both CDA, CDA. So I'm going to combine them into one column that has 11 people. Okay, and then these 2 columns, the 8 and the 4, are both DCA, DCA, now that the B is gone. So I'm going to combine them into one column that has 12 people. So this should make my calculations a little shorter too. So this is going to go 3 points, 2 points, 1 point. So 3 times 14 you said was 42. 3 times 11 is 33. 3 times 12 is 36. 2 times 14 is 28. 22, 24, and then 14, 11, 12. A is 65. C 85, D 72. So C wins. C is the winner of the losers, right? The first loser comes in second place, C with 85 points. So we put C in second. Okay, so now C is gone, right? Get rid of C, because C won. So make a new preference schedule. I have A, D, 14 people. And then my other two columns with C gone are both DA, DA. So 23 people go DA. And this is going to be 2 points, 1 point, right? So A has 28 plus 23 points, and D has 46 plus 14. So it's 51, 56, 61. Yep, so I made this new preference table. So 2 times 14 is 28, 2 times 23 is 46. So D wins this, right? So D wins the fight for not being the very last place. So we give D third place, and then A has to get last place. Yeah, so for Borda, the placing came out the same in this case. Not always like that, but Borda came out B, C, D, A using both recursive and extended. All right. Questions on Borda? All right, let's do it for plurality with elimination. Okay, so plurality with elimination, we come up with the winner, right? We've already done this. We already did plurality with elimination and determined the winner. But if we forget, we could just do it again. It's pretty quick. A is 14, B has 4, C has 11, D has 8. It was going to take 19 for a majority. Nobody has it, so we eliminate B. B's votes are going to revert to D. So D has 12, C has 11, A has 14 still. Still nobody has a majority, so we eliminate the next candidate, which would be C. C's votes, these 10 would go to B, but B is gone, so they go to D. And this one goes to D, so all 11 votes go to D. So D gets 23 to A's 14, so D is the winner, right? So D wins round 1. Go to the table, plurality with elimination, D is the winner. Now, D won, so D is gone. We're going to do it again. We're going to make a new preference schedule with no D's in it. Okay, so I have 14 voters, A, B, C. 14 would be what? CBA. CBA is 10, the 8, and the 1 all become CBA. So that's 19 go CBA. And 4 is CBA. Sorry, the 4 is BCA. Does that make sense? Right, and C has a majority, so C is the winner. Okay. Majority, C wins.
So even though we give these points to D the first time, we still keep it.
Yes. Yep. You start over.
Rather keep
Yeah, you start all over. So C gets second place. Now we eliminate C, right? C now has a place, so we are going to have a runoff where C is now gone. Get rid of C, get rid of C. Make a new preference schedule. I have 14 people that would vote A, B. Everyone else would vote BA, right? Because both of these columns become BA now that C is gone. So that's 23 BA. So A has 14, B has 23, B wins. Okay. So B gets third place and A gets last. So we have DCBA. Okay, I'm going to let you do pairwise comparisons. Now that you get the idea of like, do the whole thing, take someone out, start again. Everybody seems to have gotten through this last one, which is great. And we got C, B, D, A. All right, so what do you think? Which method do you think is better, recursive or extended? Extended is quicker, big plus. Recursive is pretty tedious. Right, if you programmed a computer to do it, it wouldn't be a big deal, right? You get a lot of practice doing recursive, yeah, so you remember it'll help you remember the methods, yeah. So extended is quicker. Recursive gets us a lot of practice. Gives us practice. But it's tedious. But we could get a computer to do it for us. It'd be pretty easy to program like Excel to do this for you. And then wouldn't matter that it's tedious.
And somehow must be a little bit closer there.
Think so?
Yeah, because the votes for the person who's going to win regardless and should win kind of regardless don't count when considering the next
one. Okay, so recursive. There's an argument to be made that it's more fair. Sure. Well, all of them consider all of the candidates, but the thing with recursive is that once we know who's going to win, whether we do extended or recursive, the winner is the same, right? So once we know who's going to win, there's an argument that this is more fair because now the people who voted for that person, right, those votes aren't affecting everybody else. We take them out and determine who would win with that person not there. So there's a little bit of a fairness advantage, but there's the tedium that goes with it. There really isn't a better one. You just have to, again, decide ahead of time what your method is going to be. So I was going to do a little summary with you, but since we only have 2 minutes, I'm just going to let you do this on your own. We've covered all of this, so you can just fill this in later. Have we found any method that does not violate a fairness criteria? No, there is not one. So we have not found one. Do you think there is a method that will satisfy all fairness criteria? You are right. There is not one. Okay. There isn't a method that satisfies all of our fairness criteria. So finding a voting method that satisfies a few simple fairness criteria, just a few things that we think are important for fairness. This is a really important question for a democratic society to answer, to say we need to find a way to vote that is consistently fair. Okay? And it was an open question. This was an unanswered question until the 1940s, whether or not we could find one. And in 1949, there was a mathematical economist, Kenneth Arrow. He proved that there is no such voting system. So his result is called Arrow's Impossibility Theorem, and it says for democratic elections that have 3 or more candidates, there is no voting method that will satisfy all fairness criteria. So it's surprising, it's a little paradoxical. It tells us that making decisions in a consistently fair way is inherently impossible in a democratic society. Which is like a little bit scary, right? Because that's how we do everything. Yeah, sure. Yep. And sticking to it, yeah. Yep. So that's about it. We won't do this group work. All set.